Hello everyone, welcome to this new episode of Radar, the podcast that takes you deep into the world of Safran, where we look at all the topics that make up daily life in the group. For this episode number 8, as usual, we will raise our heads. We will look at the stars and even beyond. You cannot have missed the incredible images taken by the revolutionary James Webb Space Telescope, whose mission is to reveal the greatest secrets behind the creation of the universe. But how were these images taken? What answers do they provide? Why is this program a technological feat? And of course, how did Safran contribute to this incredible space adventure? We will answer all of these questions with today's guest, Jacques Rodolfo, R&T Program Manager at Safran Reosc and Project Manager for the James Webb Space Telescope since 2007. So now, put on your spacesuits and get ready for takeoff. We will travel to the confines of the universe beyond space and time. Hello, Jacques Rodolfo.
Hello, Alexandre.
We hear that the James Webb Space Telescope program is one of NASA's most important projects since the Apollo missions. Can you explain us what are the stakes of this program and what is the telescope's primary mission?
Indeed, this project is the major project of the NASA. It has started in the 90s and it has kept busy the NASA's engineer for the last 30 years about. The James Webb Space Telescope is in fact a time machine. The role of this telescope is to observe in space objects that are very small and very far in distance. And this will allow to determine how they were very far back in time. So that's the major role of this telescope. It will also be used to look at the galaxies, stars, and planets and provide information about how they formed. And this will help of understanding more the theory of evolution of the universe, starting from the Big Bang. One of the stakes also of this telescope is to analyze the composition of some planets that will be observable. And this will allow, eventually, to define if there is some possibilities of life on these planets. So scientifically, this is the major mission of the NASA for the last years. And technologically, this project is a huge challenge. The telescope is the largest ever launched in space. There are so many mechanisms that needed to deploy in time, functionally and successfully, that it is considered as quite incredible that everything happened so well in the deployment of this telescope. Among those, the launch of the satellite with the Ariane rocket was a very, very significant success. And one of the challenges of this telescope is that it will operate at the L2 Lagrange point, which is 1.5 million kilometers away from Earth. And at that location, it's very interesting scientifically for the observation, but it will prevent any maintenance, repair, or intervention of any kind on the telescope. So it makes an additional challenge for the teams that everything has to go well. And up to now, it's quite a success.
You mentioned the images that were taken by the James Webb Telescope. They were revealed to the public this summer. They were absolutely stunning. And can you tell us what do they show us and how were they taken?
So just a word about the images that we see. These are false images because we see them with very nice color and very large palette of colors. But in fact, they are taken in the infrared, for which the human eye does not see anything. So they should be fully black.
Oh, so that's not so interesting then.
But there are some engineers that are very good at post-processing and that are making them visible so that we can understand how beautiful they are.
Yeah.
And when we see these images, we see that they are very sharp and on very large range of colors, which show the essence of the quality of the images and the performance of the telescope. And that's for real. And on board the James Webb Space Telescope, there are different types of instruments. There are NIRCam, MIRI, and NIRSPEC, for which Safran Reosc worked on. And some are images. They are kind of cameras. And some are spectrograph, which is the case of NIRSPEC. And the images given by NIRSPEC are not so stunning because the data are raw data that are spectrums. So there are lines of digits, which are not so very sexy. Mm-hmm. But at the end, these are the data that say that on this exoplanet, there is this molecular compound, and this will allow the scientists to understand the physics of the elements. This is the case, for example, of one picture that has been released yesterday by NASA, which is a picture of a gas planet, WASP 39b. And it has been demonstrated with a NIRSPEC instrument that there is carbon dioxide, carbon monoxide, nitrogen, which could help saying there is life on this type of planet.
Mm-hmm. Jacques Rodolfo, you were the James Webb project manager at Safran Reosc from the beginning to the delivery of this program. Can you tell us how the program came about and what was the role of the teams at Safran?
In fact, a very good memory of this project because this is the first project that I worked on as a project manager at Safran Reosc. It started in 2007 and in fact it ended at Safran Reosc in 2011. Up to the launch last year, we had very interest in following the steps and the progress of the overall project. It was a very complete project at the time, so it was a challenge in itself. It gathered all the skills and all the teams that are working at Safran Reosc, from optical design, mechanical design, polishing, thin film coating, integration, and testing. And gathering all these activities was already a challenge. Then there was a technical complexity due to the material of the mirrors, which are made of silicon carbide. And it was one of the first time that Safran Reosc polished this material. So we had to develop the polishing techniques together. Meanwhile, the project was running. So that was quite a challenge, but it was a success. And another technical challenge that we were not used at Safran Reosc was the test that needed to be performed on the telescope because they operated at cryogenic temperature.
So what are the next challenges for your teams now?
Indeed, this project for Safran Reosc has been a major achievement, and it has led to showing that Safran Reosc was mastering the technology for manufacturing and polishing mirrors in silicon carbide. And it gave suit to several major projects like Gaia, Euclid, which are scientific mission of ESA. And it also enabled Safran Reosc to show that we were mastering the polishing of optics for scientific applications, also for astronomy. And this led a few years ago to the start of the manufacturing of the mirrors for the ELT, the Extremely Large Telescope, which is the new major challenge that Safran Reosc is working on. Mm-hmm. It is a telescope for ESO, European Southern Observatory, for which the primary mirror is 39 meters in diameter. These are huge challenges for Safran Reosc now to achieve this project.
I have one last question for you, Jacques. How did you feel when Ariane 5 took off with this James Webb Space Telescope last Christmas in 2021?
Indeed, that was a very strong moment. I attended the launch on the 25th of December. That was with my family. And I was very proud of looking at this with them and to explain them what we had contributed to and how important that has been for me to work on this project. I was proud of that. On the 12th of July this year, we organized a small event at Safran Reosc with the team that I worked on the project that were still at Safran Reosc. And there were quite a few. It was quite nice to see this. But not only, there were also some younger people in Safran Reosc that joined the event, attending the broadcast of the release of the first images. And it was interesting also to see that they were also interested in this project that had been a major project for Safran Reosc in the past.
Well, thank you very much, Jacques Rodolfo, for being our radar of the day. And my dear listeners, you can find all the episodes of your favorite podcast on Insight and on your favorite podcast apps. We'll be back next year in 2023 with a new episode of Radar. Stay tuned.